Okay. Okay. Now, so let's start, Gaurav. Huh? Okay. We are looking at aldol condensation for today. Quite an important topic, aldehyde ketone mein. So, oh, okay. I'll speak in English. So the point of aldol condensation is that we are looking at a certain reaction of a group of compounds called carbonyl compounds, specifically aldehydes and ketones. Okay. So the point is that in aldehydes and ketones, when you have the alpha hydrogen, this is a major point. Alpha hydrogen in carbonyl compounds is acidic. Okay. This is acidic in aldehydes and ketones. I'm writing it in short form. Okay. The question is, why is alpha hydrogen acidic in aldehydes and ketones? Do you remember the answer to this, Gaurav? So if I draw let's say we'll draw an aldehyde or a general carbonyl compound. Carbonyl is C double bonded to O, and then there's some group, some alkyl group with hydrogen attached to it. Now, which is the alpha carbon and what are the alpha hydrogens here? If you remember, Gaurav. This CO double bond, this is our functional group. So any carbon directly attached to your functional group behaves like is called an alpha carbon, and there are three alpha hydrogens here. The important property that we're discussing right now is that alpha hydrogens in aldehydes and ketones are acidic. What do they mean when they say these hydrogens are acidic? That means they can be easily lost or taken out, extracted in the form of proton H plus. Okay. So who exactly extracts this acidic hydrogens? Point is, why is this hydrogen acidic in nature in aldehydes and ketones? Two-pronged reasons are there. First reason is that there's a strong electron withdrawing mm, tendency of carbonyl. Can you explain maybe just in a line what does this mean? Strong electron withdrawing effect of carbonyl group. So this is the carbonyl group. Yes, oxygen is electron withdrawing, so the oxygen density moves towards oxygen, becomes delta minus. The carbon attached to oxygen, so the carbonyl carbon itself, this gains a partial positive charge delta plus, right? Because of this, electron density from the adjoining alkyl group is alpha carbon said. So electron density will be pushed towards that carbon because it is experiencing lack of electron density being partially positive. When electron density is pushed towards that carbon, this hydrogen is more than willing to give up its electrons and go away as H plus. That's one point. Another point of why this hydrogen is acidic is that resonance stabilization of, sorry, one second. Can you see the screen? Resonance stabilization of, hello? Hmm. Okay. Of the conjugate base, which is produced when this H plus ion is acidic and extracted as an acidic ion. Now, point is, what is a conjugate base and what is resonance stabilization happening here? So this aldol condensation, this entire process takes place either with dilute NaOH, KOH, or things like barium hydroxide also. So essentially, we should have a base. Either here in this case, base can be, we can write it as B minus, or you can write it as B with lone pairs of electrons. So any Lewis base which can donate electrons, that acts like a base, right? Or because we are using these reagents like dilute NaOH and BaOH2, we can also have the base in the form of hydroxide ion OH minus. यहाँ तक समझ में आ रहा है? Do you get this? Okay, so let's imagine we have this OH minus working as a base. So bases nature, it's negative, right? Negatively charged, or it has excess of electron density. So what it tries to do is it tries to extract this alpha hydrogen, which is acidic in nature. As a result, this hydrogen will be extracted in the form of H plus, remember. So this bond or the electrons that are there between carbon and hydrogen of this hydrogen will be given to carbon and hydrogen moves as H plus. So essentially, in this reaction, what do you get when that hydrogen is extracted? You get this product. I'll maintain the color of the pen. So carbon double bonded to oxygen is not changed whatsoever. This carbon, which lost one hydrogen, now it has only two hydrogens left, right? And the bond that broke between carbon and hydrogen, those electrons moved to carbon, so this carbon gains a negative charge. Is this clear? And this OH minus and H together, they can be they can be removed as H2O. Get the point? Or if any general base is used, you can write it as BH also. That base takes up the hydrogen. Got the point, Gaurav? Okay, so what is this called? Carbon, any carbon that has a negative charge is called a carbanion. Okay, so you have a carbanion. Now, this carbanion can be stabilized by resonance. It can have two resonating structures, which I'll show you right now. Can you think of what would be the resonating structure for this? Yes, double bond moves to oxygen because oxygen becomes negatively charged, and this double bond, negative charge that is on carbon can form a new bond here. As a result, the resonating structure that you get is CO with a negative charge on oxygen, double bonded to this carbon because the negative charge has now become a double bond, and then there are two hydrogens present on it. This is another resonating structure of the same conjugate base. This, oh, right, this both structures, these are called conjugate base. So now you have resonance stabilization of the conjugate base. Conjugate base, what essentially is conjugate base? When an acid loses H plus. So it lost an H plus, remember, with the base. When an acid loses H plus, whatever is left of that, that's called a conjugate base, if you remember 11th standard, right? So these are the basic 2 points why the alpha hydrogen in aldehydes and ketones are acidic. That's because one strong electron withdrawing group of the carbonyl and another is resonance stabilization of conjugate base. I hope this is clear. Okay, now we will go to the actual aldol condensation. This was just a preliminary discussion on why alpha hydrogen behaves the way it behaves. Now, when we talk about the real aldol condensation, how do we write what is the mechanism of aldol condensation? This is a super important topic in 12th grade. Now, let's say we take a very simple example. I have a time limit of 30 minutes. I think we have enough time, right? Okay, never mind. So let's say we take a very simple aldehyde to begin with, CH3, CHO, right? We take it 2 times, 2 moles of the same exact aldehyde is required. I'll explain why in just a bit. Now, what do you give to it? What is the reagent? Dilute NaOH, right? And you get some product here as the product of aldol condensation. Now, let's look at the mechanism, shall we? All okay, Gaurav? Okay, now what is the mechanism of this? From NaOH, I can write it step one, step two. There's no actual step differentiation in the NCERT textbook, but we'll do it a little with more clarity. Now, from dilute NaOH, I can have a base OH minus, right? This behaves like a base which extracts the alpha hydrogen. Get the point? Get my point? Okay, let's start with one molecule of, now this is step two. Let's start with one molecule of the aldehyde, CH3, CHO. Now, which is the alpha hydrogen in CH3, CHO? The hydrogens that are attached to this carbon, right? Because this is the functional group. This part is your functional group and this is the alpha carbon. So these are the alpha hydrogens. Yes. Okay, now what happens as a result when you have OH minus, the base in the vicinity, it can take the hydrogen and the hydrogen's electron will move off up to carbon. This we've already discussed. Do you remember this? So what you get as a result is CHH with a negative charge, and then along with it, you have the CHO group intact, right? Any question? Okay, this is molecule one of the two molecules that we started the reaction with. Now, in the next step, so when we move to the third step here, what happens actually is that the carbanion, oh, this is called a carbanion if you remember, because negatively charged carbon. Now, when you have that carbanion, I'll write it like this, CH2, because two H are there with a negative charge, and then CHO, right? This reacts with one more molecule of the same exact thing, CH3CHO. Yes, we started with 2 moles, recall. Okay. So CH3CHO को how can we write CH3CHO? What we can do is write C double bond O and H here. Yes. Okay. In this step, when you have one more molecule of the same thing, what goes on here is that this oxygen can take up the electron density from the double bond. So the double bond breaks, one of the double bond breaks, and the electron density is shifted to oxygen. As a result, carbon would get a positive charge, oxygen would get a negative charge, right? So what happens at that same instant is that this negatively charged carbon of the carbanion can attack on this carbonyl carbon. So what essentially happens is one of the alpha carbons of the aldehyde attacks the exact carbon of the carbonyl group, attacks the carbon of the functional group in the other molecule. Do you get the point? Okay, and when they get clubbed together, how can we write this? We can write the second molecule first, CH3. C. Now this has become O minus because the electron density shifted, right? And it has a H, so we'll write this H along with it. Do you get the point? And at what position is this attached? It is attached to the alpha carbon of the other CH2 position of this molecule, right? We can call it molecule 1 and we can call this molecule 2. Get the point? And that CH2 is attached to a CHO aldehyde group. This is what we initially get in step 3, this particular molecule, right? I'll continue from here. I'll not make another new step. So what we can do after this is that we can give H2O to this molecule so that O minus can take a hydrogen from water, and the new molecule as a result becomes CH3, CHOH, and then CH2, CHO. Get the point? Okay. Any question? Plus, what will be left as a byproduct from H2O? You've taken a hydrogen and formed OH, alcohol. What would be left? OH minus. The base that you started with, you get it back again at some point in the reaction. Get the point? And what is the name of this particular molecule that you have obtained in aldol condensation? This molecule is called an aldol. Why is it called aldol? It has an aldehydic group, CHO group, and an alcoholic group as well. So this is called aldol condensation. We've clubbed both functional groups together. It has another very interesting and specific name as well. This is also called beta hydroxy aldehyde. Can you guess why this is called beta hydroxyaldehyde? Aldehyde being the main group here. This is alpha carbon, this is beta carbon. At beta carbon, you have a OH functional group, which is why this is called beta hydroxyaldehyde. Get the point? So two names, one more prominent than the other. Aldol is the most commonly known name of this particular type of molecule when we obtain from aldehydes or ketones. Okay. Now this one more step left in this. So we'll move to the last step, step 4. Once you've got the beta hydroxyaldehyde, in our case, it was this molecule, if I remember it correctly. Okay, I'll maintain the consistency of the colors. CH3, CHOH, and then from the second molecule, we've got CH2, CHO. This was the molecule we just wrote. Oh, by the way, we can also have the IUPAC name of this molecule. That could also help us. How can we name this? You have to start with the aldehyde group has more priority. 1, 2, 3, 4. This is how we number the chain. So what does this become? 3. Can you tell me? 3, 3 hydroxy. Great. 4 carbons. So 3 hydroxy butanal. Yes. Got it? Or butane 1-Al, but you can write butanol together. That's fine. Got it? Okay. Now, when we take this molecule up, there's just one last step. If you take this molecule and if you just heat it up, it's gonna lose a molecule of water. One water molecule elimination happens when you heat beta hydroxyaldehydes. How does it lose water molecule? OH hydroxide will be lost from the hydroxide part, and one of the hydrogens of the alpha carbon meaning the carbon next to the CHO aldehyde group, that carbon. One of the hydrogen of that carbon can be lost, so that if I'll just write it the hydrogens separately to have a little more clarity. This was initially a CH2 group. So I've opened up the hydrogen. So one of the hydrogen along with the OH will move together as H2O, eliminated as H2O. As a result, what happens is the bond between carbon and hydrogen, right? This bond, the electrons of this, do you see, Gaurav? The electrons of this bond can now move to the adjacent carbon and become a new bond there. So it works like a double bond. So when you have CH3, CH, recall this OH is lost as water, double bonded to the adjoining carbon with hydrogen and then CHO. This is clear. Any questions? Any question? Okay, this has a super interesting name. This is called alpha comma beta unsaturated carbonyl compound. Why is it called this? Can you make an assumption? What is alpha beta unsaturated carbonyl compound? So this is the carbonyl compound CHO. Alpha and beta, these two, between these two carbons, you have the unsaturation, unsaturation being the double bond. And that's why this is alpha beta unsaturated carbonyl compound. All clear? All good? Okay, how do we write the IUPAC name of this molecule? We'll again take the priority of the aldehyde group. So 1, 2, 3, and 4. And what do we call this? But at 2 position, you have ene, and at 1 position, you have Al. So this is butene 1, and this is the final product of aldol condensation. Okay, let me rephrase again very, you have a question? Let me rephrase this. Let me just make it absolutely sure. Aldol condensation only happens when there is alpha or an alpha, I don't care, alpha hydrogen. Get the point? Because that has to be extracted to be able to get this whole condensation product. So when you give dilute NaOH, if mechanism is asked, if it's a longer question, meaning 3-marker or a 5-marker question, you can write the entire thing. Or in short, what we can write is, we'll write CH2CHO, one of the molecules. So this, right? Just write it as it is, except one alpha hydrogen would be removed because it gets lost and the base extracts it. And to that CH2 group, you have CHOH. This CHOH comes from the CHO of another molecule because there are 2 molecules reacting, and attached to it is the CH3. I'll again talk about it in detail when the recording timer sets again. So this is the aldol condensation product. When you heat it up, you lose OH and one alpha hydrogen, this alpha hydrogen, because this is the functional aldehyde group. Okay, so as a result, what do you get here is minus H2O and then CH3. I'm writing from bottom to top. CH3, CH, double bonded to CH because it lost the OH group, double bonded to CH, and then CHO. This is the alpha beta unsaturated compound that we just talked about. So this is what the exact thing looks like. Did you get the gist of it somewhat? Okay, now we will quickly do the second molecule. One more molecule. We'll look at a ketone. How does the aldol condensation look for a ketone? And there's a ketonic group. So we'll take the simplest ketone, CH3, C double bond O, CH3. This is acetone or propanone. 2 moles of it in dilute NaOH. Does it have alpha hydrogen? Yes or no? Does this carbonyl compound possess alpha hydrogen? 6 alpha hydrogens are there, right? Yes. So what we will do is, again, I'll just quickly do this mechanism, CH3, C double bond O, and this C has 3 hydrogens. I'm opening them up for easier mechanistic process. Now this and OH minus from the dilute NaOH. This is our base. What does our base do? Our base extracts this hydrogen, alpha hydrogen. The bond between hydrogen and carbon goes to carbon. So as a result, we get a carbanion CH3, CO, and CH2 with a negative charge here, right? One of the hydrogen is lost, so you just have 2 hydrogen, CH2 negative. This is the carbanion produced as a result. Plus, what do you get? You get H2 in this step, OH minus and H plus. This is clear? In the next step, any doubt? Okay. In the next step, we have the carbanion CH3, CO, CH2, and this CH2 has a negative charge. What happens now, if you remember properly, there are 2 moles that we always start with. So there's 1 more of the same ketonic molecule which is gonna react with this. Now, how does this react? If you remember correctly, the next molecule, what happens? One of the bonds of the double bond goes to oxygen. This gets a positive charge. This carbon gets a positive charge. So the carbanions CH2 group can attack on this carbonyl center of the next molecule. Recall all of this. As a result, what you get is CH3, C double bond O. This all is intact, nothing is changing here. CH2. Now this CH2 is attached to this carbonic center, right? This carbonyl center. So this gets attached to C, which has a O minus because the electron density moved to oxygen. One of the bond moved to oxygen, right? And you have CH3 and one more CH3 here. This is what it looks like at this stage. Now, this looks incomplete. What do? You give water, and as a result, when you give water to this, one of the hydrogen of water, not one of the hydrogen, so H plus and OH minus in water, hydrogen H plus moves to this, and you get CH3, CO, CH2, and the next part of the molecule begins C. This becomes OH, right? Hydrogen is taken from water, CH3, CH3. This is, okay, what is this called? This is now called a ketone. Why it's called ketone? Because you have a ketonic group, ketone group, and an alcoholic group. So this is called ketone, ketone plus alcohol, right? And this can also be named, this can also be named as, any idea? Sorry. Hmm. Beta hydroxy ketone. Earlier that was beta hydroxy aldehyde. Now we've formed beta hydroxy ketone. Why beta hydroxy? This is the functional ketonic group, right? This is alpha carbon, this is beta carbon. At beta carbon, you have the hydroxy group. So beta hydroxy ketone. Yes. And what would be the IUPAC name of this molecule? Take a guess. How do we start numbering this? We number it from 1 to 2 being closest to the carbonyl group has higher because it has higher priority. 3, 4, 5. Yes. So, yes. How do we name it? 4 hydroxy. H comes first alphabetically. 4 hydroxy, 4 methyl, and what is it? 5, right? Pen, pentan, 2 ONE. Pentanon, but at second position, you have the ketone group. So, pentan 2 1, right? Is the name clear? Any question? Any question? Okay, now what happens in the last step? So this was step 2, and in the final step, I clubbed something together maybe. In the final step, what happens here is if you heat this molecule up, minus H2O happens, 1 mole of water is lost. Where do we get that water from? The OH group here and one of the alpha hydrogen. Now, what is alpha hydrogen? Which alpha hydrogen? Preferably the alpha hydrogen, which is inside in the carbon chain, not the terminal carbon, but the mid carbon, non-terminal carbon, according to Setzer's rule, if you remember. It always prefers double bond at the center position of the ring, not at the terminal position. Get the drift? Okay, so what is formed as a result is CH3, C double bond O remains intact. You have CH, that hydrogen is lost, double bonded to, now comes the next part, double bonded to this carbon, which had a OH, that OH is lost as H2O, right? And you're just left with CH3, CH3. This molecule is, what can we call this? This has a name. This is alpha beta unsaturated carbonyl compound. You can write ketone as well, right? Why alpha beta? Because this is again functional group alpha and beta. Between alpha beta, you have the double bond. All clear? All good? What's the IUPAC name of this molecule? Think. Be quick. 1, 2, 3, 4, 5. Yes. 4 methyl, 4 methyl. Then pent 2. No, no, we have to write the double bond. Pent 3 ene and then 2 ONE, right? Get the point? All clear? Any questions? Okay, this is what aldol condensation overall looks like mechanistically. And okay, where did I write this? If you need to write the product directly, how do you decipher the product? Is that we'll write the first molecule just as it is, except one hydrogen less from the alpha position. So I'll write it as CH2, CO, CH3, and the next molecule attaches from the carbonyl carbon, meaning the double bonded oxygen carbon. That carbon has to attach to the CH2 here. So you get C, and here it should have been double bonded oxygen, but it becomes OH, you know, from the mechanism if you remember. And we get CH3, CH3 here, the rest of the CH3s as it is. If you write the mechanism a few number of times, you don't actually have to do all of this. It just come natural to you. I think it looks a little messier now, but it'll be clear eventually. Do you understand how I wrote this product directly? And then on heating, what it does is this OH gets removed along with one of the hydrogen here of the alpha carbon. So this is the functional group. Again, this is the alpha carbon. The hydrogen gets removed. Setzeff's rule is also a little important here. CH3, and then you form the new double bond here. CH, one of the hydrogen is lost as water, and double bond O and CH3 minus H2O lost. Do you get the point? Okay, I think we are about to cross the 30-minute mark of recording.